You're back for a bit more maths. Well, this is sectors of a circle and a little bit on parallelograms. Same principle as last lesson. We're still using 2 pi r, pi d and pi r squared, but we're multiplying it by theta, the degrees in your circle, over 360, which is a full circle. So you can see out over on the right here, we've got that kind of situation in my Pac-Man drawing. So theta is that internal angle, whatever that is. So here, if we look at our example 1, we have a 3/4 circle. And this right angle is 90 degrees, which means this part, our theta, is 270 degrees. So let's find the perimeter. So we have 2 pi, and the radius is 2, and we need to multiply that by 270 over 360. Now that's the same as 4 pi times, like I said, it's a 3/4 circle, so 3/4 is what that simplifies to. Now we could actually write this in a slightly different way. That's the same as 4 pi times 3/4. And we can, of course, cancel those out. So this is just the same as pi times 3, or we write it as 3 pi. But that is only finding the section around here. So that part of it. It's a bit messy, so I'll get rid of those. We still have part of the perimeter, which is from here and across there. So it ends up being 3 pi plus 4. And that's in exact form, so that's as accurate as we can get it. So that's a perfectly acceptable answer. But we could put it in our calculator. So 3 pi plus 4. Again, if it doesn't change anything, press Control and then Enter, and we get it as a decimal. So that's 13.42. And we don't have a unit measurement. Really important that you generally leave it in that exact form. So 3 pi plus 4 is acceptable. Whereas 13.42 is the decimal value. Only do that if it tells you a number of decimal places. Let's quickly go through the same thing for area. So pi 2 squared times, I'm just going to start with 3/4 because we know that that's the amount of circle that we have. So that's the same as 4 pi times 3/4, and like we said, that's the same as 3 pi. I've jumped some steps there in the working, but use your calculator or just work through that if you get confused with any of that. And that's going to be around about 9 point something. You might even see these squiggly brackets, that equal sign, sorry, that just means close to, so approximate value. And again, if I do 3 and then pi, Control Enter, and it's 9.42. Okay, let's have a look at a smaller sector here. So 100 degrees, we're not working with a quarter or a half or anything like that in this circle. So we do need to use our formula. So 2 pi, that is a 2, times 7. And we need to times it by this internal angle here. So by 100 over 360. So that's the same as 14 pi. And I can simplify this by cancelling. 2 goes into that, so it's the same as 5 over 18. And we could write this, and it's going to get a little bit messy, in exact value, 14 pi times 5 over 18. We can cancel these to be 9 and 7. And we can actually put these together, so 7 times 5 is, of course, 35. And I think that's all we can do. It's the best we can come up with that. Of course, we can't forget about these sections here. So 7 and 7. So we need to add 14 meters in this case. So that's 35 pi over 9 plus 14 meters. Again, you'd probably want to use your calculator for that. Again, if you press Control Divide, you can do 35 and then pi divided by 9 plus 14. Again, it'll give you that in exact values, but 26.22 is what that would become. meters. Area, same kind of thing, pi 7 squared times 100 over 360. And just use your calculator for these ones. If it's quadrants or if it's a quarter or a half of a circle, you might need to do it as an exact value, but usually for these you'll have a calculator to type in. Oops, it should be 49 pi. Times. Just make sure it looks exactly like it does on your bit of paper there. The calculator will give you the simplified version, so you can certainly use that. But let's do 42.761. So that equals 42.761 meters squared. I'll quickly write out this one. So this would be 2 pi 5 times a half. We have half a circle. So that's the same as 10 pi times a half. Timesing by a half is the same as dividing by 2. So that's the same as 5 pi plus 10, which is our full length along there. So don't ever forget that straight line that crops up. Area, pi 5 squared times a half. So that's 25 pi. Again, like I said, timesing by a half is the same as dividing by 2. So you can just write it like that. You might want to put that in the calculator and find out the approximate value, but I'm not going to do that right now. Alright, parallelograms and trapeziums. Might do this in a no, we'll finish it off in this video. So parallelograms, because this section here, this little triangle over here, would fill in that section. It's just the same as a rectangle. So we can do base times height. Trapeziums are a little bit more complicated. It's the length of the bottom of it plus the length of the top times the height, and then multiplied by 2 or divided by a half. So you could write this as a plus b times h over 2. That's exactly the same thing. So area for this one's pretty straightforward. It's not 3, it's not 2, it's 3 times 1.5, which is 4.5 centimeters squared. And the area for this one, a little bit more complicated. So 4 plus 6 times 3 over 2. So that's 10 times 3 over 2, which is 30 over 2, which is 15 meters squared. And this one doesn't look like it, but it's actually a trapezium. So we can use those same values. So there's a couple of ways that you can do it, but let's do the perimeter is a bit more complicated. Let's do the area first. So that is 3.1 plus 4.2 times 1.7 all over 2. I'm going to have to go to my trusty calculator. And then I'll divide that answer by 2, so 6.205 meters squared. Perimeter is a little tricky for this one. To find y, we're going to do 4.2 minus 3.1, which is 1.1. So that's just this part of the triangle. So we've got the base of the triangle being 1.1. We don't know what x is, and we know that this is 1.7. And we can use Pythagoras now to find that unknown length. And we'll need our calculators for this one. So let's have a go at that. In fact, let's just write it as x equals the square root of 1.7 squared plus 1.1 squared, and then the square root of that value, which is going to be 2.02. So was that 4.1, x equals 2.02. We can then add that to all our values, so that's just this length here, 2.02 plus 3.1 plus 4.2 plus 1.7, which is going to be 4, 5, 6, 7, 8, 9, 10, 11 point. Have I missed anything? So that's 9. No, it's not. I think that's right. You might not want to check my working, but that's a bit of a tricky way, but you might need to use Pythagoras to find different lengths through these units. That is a huge video, but they are two quite big sections. Again, just remember your different formulas, write them down somewhere. I'm sure you'll do very well.